Still on exponential equations, we have to solve for x. So we look at the sum and we see that it is exponential because of the x being in the exponent. So you know that the rule you're basically always searching for is for sum of the same bases. What do you think the base is going to be? Why? Because it's with a quarter. Not at the moment, the 8's not my problem. But if I look at the quarter and I know it's going to become prime factor 2, although it's at the bottom, we change it to the top. I'm thinking we should be aiming for 2 something with the x there equal to 2 something something. That's what we're aiming for. Then you know what you're going for. So how do you think we're going to solve this? Distribute the 4 into the brackets. I will hurt you. You're not allowed to time it in. Right? What can you do with the 4? Divide the other side by 4, which gives you 2. So divide by 4, divide by 4. What are you going to do with the quarter? Make it? So you can do that in one step, but there's a lot going on there already. First, we divide away the 4 on both sides to get to 2. You cannot time this in because this is a power of which the 2 make up 1 unit. You can't do something with the base or something with the exponent with something else. That's 1 unit. So divide the 4 away. And then we want to get this to prime number as well, which is 2, and take it to the top, which is 2 to the negative 2. Giving me 2 to the negative 2x plus 2 equals to 2 to the 1. Meaning I've got my basic principle. 1 power on either side. Then I can say that the exponents must be equal to each other as well. It's a principle. If the power is equal to the power and the base is equal to the same base, then the exponents have to be equal. So we've got negative 2x equal to negative 1 and x is equal to a half. Now this is linear equations. If the x are, now whichever way you want to swing it, it's fine, as long as you get to x is equal to a half. Okay, next one. What do you think we're aiming for? 3, right? 3 to the power. These are all sorts of 3s. What are we going to do with that root? What are we going to do with that root? It's going to be 3 to the, right? And in that same step I can say, take it to the top, this 1. When the bases are the same, of which this exponent is 1 over 2. Divided by means I've got to subtract the exponents. Again, 2 steps in 1. It's going to be a half, which it should be with a mark. It's going to be bases the same, so we subtract the exponents. And this one then just stays x plus 1. Then it's quite easy. If you want to do it step by step, it's fine. But at some stage you're going to have to realize, I can't have 2 things there. I've got to make it 1 power, subtract the exponents, and a half minus 1. Right, then powers equal to each other, 1 power on either side, bases are the same, so x plus 1 is equal to negative a half because I'm subtracting. X is thus equal to negative 1 and a half, negative 1,5, negative whatever you want to write. Normally we write it in proper fractions. Can we test? If you go back to the sum and substitute the x there with negative 3 over 2, you're going to get some answer. Look at that side, put it in the calculator, you're going to get some answer. And those answers, usually when you take it to decimals, you'll see that they are the same answer. Okay, next one. What's different?
It's equal to 0.
Equal to 0? Quadratic? Power of? Equal to 0. I'm not hearing what I want to hear. Factorize. That's what must stand out for you. To factorize. Can I factorize? What's the type number 1? Common factor. No. Because this 9 is going to become? You can then split it up. Because we're on our way to factorization. If you start doing something with those bases, like subtracting the bases, I've seen weird stuff in your tests. And doing some sort of stuff with the exponents, adding them, subtracting them, 0. You're on the wrong track. You have to be able to factorize. Can I still factorize? So can I take out a common factor? Remember, if you do take it out, because sometimes we do and sometimes we don't. If we do take out a common 3 to the power x, what's left? 3 to the x, which you must know is true because when I time and the bases are the same, I add x and x to get to 2x. I'm happy. Take out the 3 to the x there, what's left? 1 over 9, right? 3 to the negative 2. In some of the other sums, we wanted to do that there, but there was another plus something there. Then it doesn't help. Why is this helpful? Because it's two things timed, factorized equal to 0. So that means that the 3 to the x can be equal to 0 or 3 to the x equal to 1 over 9. Now, in retrospect, I should have actually left that 1 over 9 as 3 to the negative 2. But I can do it later on again. I could have kept it there. When do I do it? When don't I? Sums differ. In each sum you're going to assess. Why am I doing it? Because here's power equal power, base equal base. So x is equal to negative 2. What can that x be so that the answer will be 0? There's no real solution. There's nothing that I can put there in the place of x that will make this whole thing become 0. Nothing. I can make it very small, but it's not going to get to 0. I can make it negative 2, it's a third. Negative 3, it's 1 over 27. Negative 4, it's 1 over 81. It's getting smaller, smaller, but it's going and not getting to 0. Because actually what we're busy with, thinking about graphs which are coming later, if you look at the exponential graph, this was my graph, and I say look at this graph, you should be knowing that this plus 0 is my asymptote, which means I'll always be coming closer and closer to y equal to 0, but never touching it. That's why it can never be equal to 0. Or thinking about it, what can I put there in the place of x so that my answer will be 0? It's nothing that will make it 0. It's going to come closer, 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 but it will never actually touch the 0. That's just manipulating your brain for later. Okay. What type of an equation? Exponential. What's up with this equation?
There's a precedent for this,
So, factorize. Only thing you've got to do is factorize. Can I do the same as with that previous one? Because this will now be 16 is? Do you think we're going for 2? Or can we stay with 4 maybe? 2. I think we're going for 2, right? So if it's 2, it's going to be 2 to the power 4x. You can first put it in the bracket. It is 2 to the 4 times the x will be a 4x. This one will be 2 to the 2x. But can I then take out a common 2 to the 2x like we did in the previous one? Why not? Because there's something floating around there that wasn't floating around in the previous sum. If there was nothing there, I could take out the 2 to the x because it's equal to 0, and then you can do the same as we did in the previous sum. No, because there's an 8. Why do I take the 8? I'm trying to get everything to prime numbers. Is the 8 going to help me? Is the 2 to the 3 going to help me? If you left it as 2 to the 3 for now, it's fine. No problem. But, what do you think? K method. Didn't I do the K method in the previous one as well? It wasn't necessary, but it could have helped you. But this one, I think yes. What type of factorization is this if you had looked very hard, very hard? This is a quadratic trinomial, of which the variable is what? It's 2 to the power 4x. The coefficient is 1. What's the variable? 2 to the 2x of the coefficient, which is 2, which is actually supposed to be in the front, and the number there at the back. And if you can handle that, and you can factorize that, perfect. I suggest K method. So we let or set K equal to 2 to the 2x. Are you with me? So then this will be, are you sure it's square? I'm also sure it's square because That is 2 to the 2x times 2 to the 2x, if you're thinking about it. Because when you time, you add exponents. So k times k is k squared. What's happening here? Plus k times 2. 2k is just better written. And minus the 8, which looks much more civilized. Then we factorize it. How? With our trinomial, with our James Bond technique. Or if you've got the new calculator, it'll help you with that. This wasn't such a difficult one anyway, but let's do it. So 1 times 1 and 2 times 4 for 8. Cross multiplies 2, cross multiplies 4. To get to plus 2, it's got to be a plus 4 and a minus. And then all of this SPI language stands for something, that it's going to be with a k. K minus 2, k plus 4. How you get to that is not my concern. I don't need to see that. And then your answers would be k is equal to 2 or k equals to negative 2. Oh, sorry, negative 4. And then the k still has to be substituted with 2 to the 2x. This was 2 to the 1. So my rule comes only later on in the sum. Powers are equal, bases are the same, so 2x is equal to 1. And if you immediately wrote x is equal to a half, that's fine. That one is going to be 2 to the 2x equal to negative 4. There's no solution. Some of you might have written, I'll make the 4 2 square. Doesn't matter. The problem is this is definitely positive. Doesn't matter what the x is. It's not going to change this into a negative. Nothing I can put in there will make this sum a negative. It'll make it very big or very small, but not a negative. It has to stay a positive. You've got to get that idea, because that's true. But then wait, what? Then you might say 2x is equal to negative 2. You're breaking your own rules. If it's negative, we've got no real solution. I like that very much. There isn't a solution for that. Answer is only x is equal to a half. So when you go back right at the beginning and put in a half there, 2 times a half there, and work the whole thing out on the left-hand side, it should be equal to 0, making the equation true. Last one for homework. You think factorization is necessary, key? Okay, and it is actually a quadratic trinomial. Think about it. Quadratic trinomials are normally like this, k squared 2k minus 8, right? Or x squared x. This one is usually double that one. Or that one squared is a better word. Is this still true though? Minus x. So we're ending off on a very bad one. K squared, or just 1 and a minus 1. It's not like a, what's going to help me? But then what's going to be k? Because this is 2 to the x. This is 2 to the negative x. But I can make them the same. Please don't make 2 to the x, 2 to the negative x. Leave it. Make that one. 1 over, right? So that will mean 16 over 1 times 1 over 2 to the x. Or like that. Do you follow what I did there? So it's 2 to the negative x that becomes at the bottom. Guys, very careful. Some of you did that in tests. You want to say that if it's a negative 2 to the x, you write it as 1 over 2 to the x. You have not got the rule down there. You're thinking something about changing signs. This is not true. When things go from the top to the bottom or the bottom to the top, it's going to be multiplication. And then the exponent changes sign, not the number value. Okay, if you were thinking that, don't anymore. And then for the rest, negative 10 equals 0. You have to do the k method. And for k, you're going to let k be equal to 2 to the x. Sum becomes k. So 16 over k. Which is much better than what it was, but still, what do you see? Equations with fractions. What's the rule? Toolbox. LCD. And the LCD is?
Okay.
Okay. And red light, red light. We're dividing by a variable. So it better not be 0. Okay, those are the trimmings or icing on the cake, making it perfect. But whenever you are dividing by a variable, you must make sure it's not 0. Whenever there's a root inside, make sure that there's not a negative and an even root. Whenever there's an exponent and there's something with a 0, make sure it's not 0 to the 0. 3 red lights, okay? I think this is not going to have any effect on my sum whatsoever, but let's be complete. If I do, then what do I do with the k? The LCD. You multiply the left side and the right side, which will have no effect on the right hand side. And the left side, if I times it, it's going to be every single term. Whole side times with k means times k here, times k there, times k there. What's the purpose? So that there's no more fractions. If there's fractions, why do we get LCD? After doing LCD, there must be no more fractions. That's why you do LCD. So what happened to the sum? It became k squared plus 16 minus 10k, which is a quadratic trinomial. What are the coefficients for my James Bond?
1 and 16.
Okay. What must I do?
Standard form.
Please turn it around so it's ax squared plus bx plus c. Well, it's k now, but so that it's in the correct form. You cannot factorize that unless it's in the standard form. Right, now the factors are, what times what is 1? What times what is 16? It's 1 times 16, 2 times 8, and 4 times 4. 2 and 8 is going to help me. Right? Cross multiplication, I've got to get to negative 10, so minus minus. So I'll read k minus 2. And from there, k minus 8. And make sure when you finish that when you multiply it out, it gives you the correct sum. So k is equal to 2 or k is equal to 8. Finished.
No.
Don't forget, you've got to go back and substitute k with 2 to the x, meaning this one will be x is equal to 1. No problems there, no solutions, something funky. This one, 2 to the x will be 2 to the 3, so x is equal to 3. Oh, fantastic. No, everything worked out perfectly. Right. So the next section of work is still in exponents, although it doesn't look like that. Because the sums, have a look at them. What's different now from exponential equations? Is this still an exponential equation? Technically not. Exponential equations is when the x is in the exponent. You hear x in the exponent. Doesn't have to be x, can be a, b as well, but you got the drift. Now we're solving for x. Let's go back to basics, grade 8. How do I solve for x? You try to get it alone. What do you think we're going to do with that half thing? Get it away. Just get it away. Okay, so erase it. No, you can't do that. What do you do? Times by 2 over 1. Because in equations you can do whatever you like, as long as you do it legally. So you're going to have to say on the other side as well. Are you with me? Mission, get x alone. Is x alone? Because that's going to become 1, which is just x. Equal to?
16.
Boom. That's it. But let me just take you back. What does it actually mean if I have a rational exponent? If there's a fraction exponent? Actually, what I'm saying in that same sum is not x to the half. It's actually... Please don't go back to roots, but just explain to you what it's all about. So when you've got rational exponents, you're actually busy with roots. Those rational exponents are actually roots. So roots have some problems. One of the problems is you cannot have a square root here and get a negative answer there. Okay? So if this was a negative, you would have told me no solution. There's nothing I can put in there that will give me a negative answer because it has to be a positive. Okay, that's one of the things. Then the other thing that can happen is you've got something like x squared equal to 25. How would you solve that x? What would you do? Square root both sides. And the answer is?
5.
That's not all.
Plus minus.
Yes, excellent. Plus or negative 5. That doesn't mean approximately 5, okay? Either 5 or negative 5. You were taught that like in grade 8, 9. And lots of kids forget that in the sum. Every time when I ask you which number squared will give you 25, then it's either 5 squared that gives you 25, but what about negative 5 squared? Because negative 5 times negative 5, if you square it, it's still positive. So this is a rule that you've been taught a long time ago. I see you've forgotten a little bit about it. So if you square root both sides, you've got to write plus and minus. So this is what all of this nonsense here is about. When you get into a sum, and there's a fraction, I'm trying to explain it backwards so you can actually understand. So it means that that top thing there, if it's even, I don't even have a fraction there, but okay. If it's even, your answer must always be plus and minus, whether it's a fraction or not. So if this fraction has an even number at the top, your answer must be plus and minus, whatever the answer must be. Just like here, plus and minus, because we're going to look at the examples now and hear if you've been listening. Second thing that can happen, can I have a negative answer? Only if this was uneven. Where does the 3 or the uneven one sit in the fraction? It's the bottom one. So that's why this rule here is not some stuff that we threw together. That's actually your root size. So if that answer is uneven, then this could be a negative. So I say even if it's even, that n, the answer cannot be equal to negative. Let's say star. That answer there can't be a negative. Okay, now that's a mouthful, which basically just comes down to, you're going to say, no, I don't know when it's a plus and a minus, I don't know when it works and when it doesn't. Just do the sum. Instinct helped you here. And then thinking to yourself, I don't know when it's plus and minus, and I don't know if it's right or wrong. Test it. If it works, it's fine. And then you might think, should I say plus and minus? So test and see. If it's negative 16 to the power of half, what a calculator will do, and it will give you something like non-real error, whatever, then you know it's not there. Okay, now this is not a very good way of teaching maths, but I know that you guys are going to forget this. So in the end, you're going to sit there and think, there's some funky stuff going on here, I don't know what. So test it, whether there must just be one answer, test for both of them, plus and minus, and if neither of them works, you say, no solution. And then you should be fine. If you don't do that little tricky thingy, you're going to lose one more. First example, is there anything of that which I just said that's true? Is it an even exponent originally, before I started doing stuff to it? No, because the 1 is not even. So should this be plus and minus? No. The thing about being negative, well, it wasn't negative anyway, so who cares? Are you with me? So this answer is perfect, and you would get 2 marks for it. One for the squaring on either side, one for the answer. Lekker? Okay? Let's look at this next one. If I have instincts, how do I get that next amount? To the exponent 3 over 2. To the exponent 3 over 2. And color helps you to see what your sum was and what it's now become. Then this will just be x, right? And on that side, what am I going to do to change that? Because remember now we're busy with exponent laws. It's still exponent laws in the exponent chapter. Yes, please make the 4 a 2 squared. And what's going to happen then? When you time fractions, you time the top, you time the bottom. Well, the 2 over 1 is going to cancel out with the 2 at the bottom there. You're going to be left with 2 to the power 3, which is 8. Okay, you're losing a mark here. Now we've got to check. The moment that you see these rational exponents, you must think check, 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 check. What must I check? I can't remember anymore. Is there maybe not a plus and a minus? And if you check this in the sum, it would have been. If you go check on your calculator and you put in 8 to the power of 2/3, your answer will be 4. But if you put it exactly like that with a negative, your answer will still be 4. So what does that mean? Your answer should have been a plus or a minus. Now actually, and we don't deduct marks for that, actually the moment that you did this, you should have said plus minus. plus minus. Who's going to forget that plus minus? Lots of kids. How many marks are going to lose? 1. Okay. Isn't there something that shouldn't happen here? That only is the case if the answer here was negative. Okay, then you'll check for it. No problem. It's a cube root and answers can be positive. Everything's perfect. So always double check. But if you forget everything else, and just remember when there's a 2/3 exponent, multiply by the reciprocal of that, you should be getting all but 1 mark all the time. That's the big principle of it. Okay, let's have a look at number 3 as an example. So we've got, what are you going to do?
Square.
Right. You're actually busy doing the wrong thing, but let's check it out. X is equal to?
16.
Go check it. Go check on your calculator 16 to the power of half, and the answer is going to be plus 4, which means what? But this cannot be. It's not plus minus. There's no solution for this thing. When you finish, you think positive, negative, it's neither one of them is going to help you. The plus is not going to work, the minus is also going to give you an error, so what now? The only thing you got doesn't work. So there's no solution. If you think about it before you start, actually we've been doing this all the time. What number again, Mondiwe? Is this plus or is it a minus? Plus. What can I put there inside of this x so that the answer can be negative to that exponent? Remember that this exponent is a root. A what root? A square root. It's a square root. So I'm asking you, what root can be negative 4? If you write it into root form, sometimes you're more likely to see the error of your ways. There's nothing I can put there that'll give me a negative answer. Okay? Are you seeing the checking stuff? But in essence, what you're doing is timing by the reciprocal. Get into your answer and check it. Check if it's the plus and the minus, and if none of them work, there's no solution. Are we on the same track? There's the math, but I'm helping you cheat sheet here. Okay. So actually, you should have just immediately said no solution. For this one, no solution.
Yeah.
Why? Negative answer for a square root. No solution immediately. Okay, but it looks like it's working. Because what do? You're going to say to the power 2, 3, and everything looks like it's working. But what you're doing in essence is you're throwing away a restriction when you do that. X is equal to, and the answer will then be also, it's a square, so this will become a plus. It's going to be 4. Just do it on the calculator. But go check yourself and see if 4 to that power does give me negative 8. It doesn't. Then you think, oh, maybe it's negative. Check the negative. It doesn't. What does that tell you? No solution. Okay, so I'm doing it for a purpose because most kids can never get those rules down. You should actually always just check. If that's a 3, there can be a negative. But if that's a 3 at the bottom, I'm looking wrong. If that's a 3, this can be a negative. Then we can carry on. Because that means a cube root can have a negative answer. If that was the 2, then your answer should have been 2 of them. Because even exponents must give me plus and minus. So if all else fails, guys, that aren't getting 80s and 90s, what do? Reciprocal, everybody gets their marks, but this one would just have been 2 marks for saying no solution. Once you're done there, test. Test the 4 and test the negative 4. And then you're going to see neither of them works, meaning there's no solution. Please remember, what it comes down to is if ever you said x squared is 25, you had to go square root them, and the x was plus and minus. So that's the one rule, with it being even. That's why you've got to have a plus and minus. The other one was the n being even means you cannot have a root that's equal to a negative answer, so that'll be a no solution. Okay. So Similar sums on page 19. There's your homework. 1 A, B, D, F, G, H, N, O, P.